Hey guys, I want to go over some of the questions on the review so you are ready for the test. So if you have time or you want to go back and just review one of the questions that we did in class, you can use this video as a resource. Hopefully it's also helpful when it's time for our semester exams. So the first topic, we talk about relations and functions, domain and range to each relation. And the big thing to remember here is that with our x's can't cheat, right? Remember, that's why they're x's, okay? If they're cheating on us with multiple y's, then it's not good, okay? So if we see any repeats in our x's when we're looking at tables, when we're looking at maps, we know that it's not going to be a function. Okay, so let's look at these examples. Number one is a table. They tell us to list the domain. Remember, with that, we're going to put the bracket, and then we'll write each domain value, except we're going to make sure that it is in order from least to greatest. So that's all of our x values. So I'm going to do 5, 6, 7, and 8. All right. And then for the range, it's all of our y values. I put my bracket, and then I'll list the range values. 5, 6, 7, 8. Now, is this a function? If I look at the function, my x's are not repeated in the table. They're not cheating. So yes, this is a function. Number 2, they have a map. Again, we're making sure that our x's are not cheating. Okay, so they're mapped to only one y. And if we look at that, none of our x's are cheating. So I can go right now and just say that yes, this is a function. I'm going to go ahead and list the domain. Again, I do my bracket, and I list the values from least to greatest. -2, -1, 3, 5, all the x values. Now I'm going to list my y values. -7, 0, 4, all my y values. All right, now I'm going to move on. They give me a graph now, and they ask me, is it a function? And how we deal with graphs is our vertical line test. Okay, remember, we drop in a vertical line, and if the vertical line hits only at one point, it is indeed a function. And if I drop a vertical line across the graph, I get the same deal. It's only hitting at one point. So this would be a function. So I can say yes to that. Now, if I talk about the domain of the graph, I want to talk about how far across the x-axis this graph stretches. Look at it. It only goes from negative, is that 5? 1, 2, 3, 4. Yeah, so -4 all the way to 1. So we're looking at how far across it goes, and it's only -4 to 1. So my range is going to be from -4 to 1. When I write this in interval notation, I'm going to include -4 because it's a closed circle. However, because there's an open circle at 1, I'll just write 1 and I'll do a bracket, because it's not included in our range, all right? Or I mean our domain, in our domain. Now in our range, we're gonna look up and down, how far across the y-axis this graph stretches. If I look, I notice it starts at -3. So it starts at -3, and it goes all the way up to 5. Okay, so -3 to 5. Now, if we're writing this in interval notation, we're going to put a parenthesis first, at -3 because -3 is not included in the range because it's an open circle. And then we go all the way up to 5. We're going to put a bracket because 5 is included in our range. All right, let's move over to the next one. And first, let's just determine if this is a function. I drop in my vertical line and I realize it hits at exactly 2 points. So this would not be a function. No, it is not a function. So let's talk about the domain and the range. Again, I'll look and see how far across the x-axis it stretches to discuss the domain. So the domain of this, it starts at -3. Okay, so it starts in -3 and it looks like it goes all the way out to infinity. Okay, so my range is going to be a bracket at -3. I'm including that, and then we go to infinity. And I think I said my domain. My domain is -3 to infinity. My range, I look up and down, and I see where this graph covers up and down, okay? Notice that the graph just keeps going infinitely up, and it keeps going infinitely down. So when I talk about the range of this graph, this range is going to be from -infinity to infinity, or all real numbers. All right, let's move on, and we're going to discuss now let's discuss inputs on functions. So they give us g, they say find g of -5. They give us g of x. They say g of x is x squared minus 8x plus 21. So I know that I'm going to put -5 everywhere I see ax. So -5 squared minus 8 times -5 plus 21. Now I can evaluate it. I can simply plug it into my calculator. That's what Miss Bennett is going to do. So I plug it into my calculator, and I have a -5 squared minus 8 times -5 plus 21. All right, so I know this is 86. G of -5 is 86. All right, they say find f of 11 over 2. Well, I just plug that into f of x. F of x is equal to -4x plus 1. So I'm saying f of 11 over, not 2, 11 over 12 is -4 times 11 over 12 plus 1. Now I already see something here. I can do that cross division. So this would be a -1 times 11 over 3. Okay, so f of 11 over 12 is the same as taking a -1 times 11 over 3 plus 1. And I'm going to just plug that into my calculator. So let's see, -1 times 11 over 3 plus 1. All right, and I want to do it as I want to have a fraction. So I'm going to make that answer a fraction. So I just hit the math key, and I'll just hit fraction, and I'll press enter, and bam, it'll give me my fraction. So that is -8 over 3. All right, let's go to the next one. Now we're going to take h of 8 and subtract it from f of -7. So the first thing that I'm going to do is evaluate what h of 8 is. So h of 8 is equal to the absolute value of 9 minus 3 times 8. Okay, I plug 8 into h. All right, let's go ahead and evaluate that. Well, that is absolute value. We find that in numbers of 9 minus 3 times 8. 15. Okay, so h of 8 is 15. Then f of -7 is -4 times -7 plus 1. So I'll plug that into my calculator. -4 times -7 plus 1. That's 29. And now I just add the two together, or not to add the two together, I subtract the two. So I'm going to say, hey, h of 8 minus f of -7 is equal to 15 minus 29, which is -14. All right, let's go to the next one where they say find g of x plus 4. Now we're evaluating, we're going to plug in x plus 4 or the function inside of g. Okay, so we have like a composite going on here. Well, g of x is x squared minus 8x plus 21. So everywhere I see a x, I'm going to plug in x plus 4. So g of x plus 4 is equal to x plus 4 quantity squared minus 8 times x plus 4 plus 21. Okay, and now I'm going to simplify this. X plus 4 is the same as saying x plus 4 quantity squared is the same as saying x plus 4 times x plus 4. Okay, if I simplify that, that's going to be x squared plus 8x plus 16. Then I have to distribute this -8 inside of x plus 4, so that would be -8x minus 32, and then I would have the plus 21. Okay, let's simplify it all. I'm going to change the color here so we don't see so much blue. Let's go for red. All right, I'm going to go ahead and combine the like terms. I only see one x squared. Then I got an 8x here and a -8x here, so those cancel. And then I have a 16 and a -32. Well, that's -16. Okay, -16. And then a -16 plus 21. Well, that's equal to a 5. So g of x plus 4 is equal to x squared plus 5. All right, let's go to the next one where it says if f of x is equal to 53, find x. So what I'm going to do is go backwards here. I go to f of x, which is f of x is equal to -4x plus 1. And now I have to move backwards. I have to set this equation equal to 53. So I'll say, hey, 53 equals -4x plus 1. And I'll just solve this for x. All right, so I'm going to change my pen color. I'll subtract 1 on both sides, and I end up with 52 equals -4x, and then I'm going to divide this by -4, And if I look at this, negative 4 goes into 5 one time, right? And then I have 1 left over, all right? So it goes in one time with 1 left over, so I'm thinking 12. 12 divided by negative 4 is negative 3. So this is negative 13. X equals negative 13. Okay, let's go to 10. 10 says if h of x is equal to 39, find x. So again, we're going to go backwards. Let's go to h of x. Now this is interesting. All right, h of x is 39. So I'm going to set 39 equal to the absolute value of 9 minus 3x. Okay, but here's the deal. When I'm solving these absolute values, I know that what can come out of this absolute value could be positive or negative, because we're talking about distance. Could be positive or it could be negative because we discussed distance. So that means that I can say, hey, 39 is going to equal the negative of 9 minus 3x, or 39 is going to equal the positive of 9 minus 3x, which is 9 minus 3x. Okay, the negative of 9 minus 3x is negative 9 plus 3x, okay? Let's solve this side of the equation. Okay, I'll add 9 to both sides. I get a 48, and that equals 3x. I divide by 3 on both sides. And if I look at this, this is another case. 3 goes in there into 4 one time. Okay, so that's one time. And then I get 1 left over. 3 goes into 18 6 times. So I would end up with a x equals 16 for the first side of the equation. All right. Now if I go to the other side of the equation, or the other value, when 9x plus 3 is positive, I'm going to subtract 9 from both sides. I would get 30 equals negative 3x. And then I divide by negative 3 on both sides. And x could also be negative 10. So in the absolute value, you can get both the positive and negative output, right? Because absolute value is distance. Distance can go from the negative side of the number line or the positive side of the number line. Okay, let's move on. Okay, guys, let's look at the next topic where we talk about linear equations in the different forms. The first set says write each equation in standard form. And let's recall that standard form is ax plus by equals c. So I need to get the equation in that form, and I got to remember that a has to be greater than 0, okay? And so that means that it can't be negative, okay? And then I also have to remember that b can't be a fraction. So b is not a fraction. Okay, so we don't want any fractions. A has to be greater than 0, so a cannot be negative. Here we go. First things first, I want to go ahead and get rid of the fractions. So the first thing Ms. Bennett is going to do is multiply both sides of this equation by the denominator of the fraction I see, which is 3. So when I do that, I'll end up with a 3y equals negative 2x plus 9. Got rid of the fractions. Now I need to move my negative 2x over so I can have it in this ax plus by equals c form. So that means I'm going to add 2x to both sides. Now this is good. I got 2x plus 3y and it equals 9. This is in standard form. I'm good to go. Okay, good to go. The next one says 5/8 x plus 3 over 4 y equals -1. All right, so the first thing I'm going to do is get rid of the fractions. Now, what I want to do is multiply by the biggest denominator. In this case, it's the 8. So I'm going to multiply everything by 8 to get rid of all the denominators. And what will happen when I do that is I'll end up with a 5x because the 8's will cancel here. And then over here, I'll end up with now be careful, the 4 cancels out because it divides into the 8. However, the 8 turns into a 2, so I got to take 3 times 2. So this will be plus 6y, and that equals -8, right? We're still multiplying by 8. Now, I'm good to go. It's already in standard form. ax plus by equals -8. My 5 is positive. We're good. Let's go to the next one. Write each equation in slope-intercept form, then graph the line. Okay. So, let's look at this. I am going to turn this into slope-intercept form, and I need to recall what that is. Remember, slope-intercept form is y equals mx plus b. So I need to get both of these in the y equals mx plus b form. All right. In order to do that, I am going to subtract x. I want to move that to the other side of the equation. So I would have a -5y equals -4x minus 10. And then I want to solve again this whole equation for y. So I'm going to divide everything by -5. When I do that, I end up with a y equals positive 4x over 5 plus a 2. Now I can go ahead and just graph this based on the rise over the run. So I know I start at 2. That's where my y-intercept is. I rise up 4. 1, 2, 3, 4, and I go over 5. 1, 2, 3, 4, 5. I need 2 points to graph a line. I have my 2 points. There's my line. All right, and it makes sense. Okay, my slope is positive, so it makes sense that my line is going up. Now, let's go to the next one. Again, I want to solve this for y to have it in slope-intercept form. So I'm going to move my y to the left by subtracting 4y. And I end up with a -4y plus 12x equals -28. And then I want to move this x over, right? Because I want to get y by itself. So I have 4y equals -12x minus 28. And then I want to divide all of this by -4. So I end up with a y equals positive 3x plus 7. Now I can go ahead and plot this line. So my intercept is going to be at 7. So 1, 2, 3, 4, 5, 6, 7. Right here at 7. Now I'm going to go down because the slope is positive, but I'll fall down 1 and go to the left 1 because I don't want to go off the graph. So I'll fall down not 1, 3. I'll fall down 3, 1, 2, 3, and then I'll go to the left 1. So I can stay on the graph. I need 2 points to graph a line. I got my 2 points. There's my line. Okay. Let's keep moving on. Okay, the next one says, give an example of a line that is parallel and a line that's perpendicular to each given line. So here we go. An example of a line that is parallel. Well, I know parallel means that it has the same slope. Okay, for our parallel line. Same slope. Perpendicular means that it is the opposite reciprocal. Okay, so that's our perpendicular line. So first, I want to figure out what the slope is. I'm going to put this in slope-intercept form. So I will solve this for y. I'm going to move this 9x over. So I have 6y equals negative 9x minus 6, and then I'll divide this whole equation by 6. Y equals negative 9x over 6 minus 1, and we can simplify this. That's going to be 3 over 2, so y equals negative 3/2 x minus 1. Okay, so if I talk about an example of a parallel line, I can do any line that just has a different y-intercept. So I can say, hey, y equals negative 3/2 x plus 1. That's an example. It's a different y-intercept, but it's going to be parallel to this same line. Perpendicular. It has the opposite reciprocal slope. So it's going to have a slope of positive 2 over 3, and I can just pretty much keep the equation the same. Y equals 2 over 3x, and then I'll just do minus 1. Yeah, just a different line that has the perpendicular slope. All right, let's go to the next one. I need to give an example of a line that is parallel or has the same slope as y equals negative 5. Remember, this is an example of a horizontal line because this is when at every single x value, y is going to be negative 5. So I'll see a horizontal line at negative 5. If I want an example of something parallel, I'm going to write a line that's also a horizontal line, but just put it at another value. How about negative 4? Okay, y equals negative 4. That is a parallel line. Perpendicular line has to be something that's opposite that. Well, what is opposite of a horizontal line? Well, that is a vertical line. Okay, and we know the vertical lines are our undefined slopes, or when we talk about at every x value, every x. So what that means is I'm writing an equation for x equaling a value, and I can pick any one. X equals 2. Well, x equals 2 is going to be perpendicular to this horizontal line. At every x value, we'll be at 2. All right, let's go to the next one where it says find the x and y intercepts of each line and graph the line. The only way to do that, guys, is if your equation is in standard form. That's the only way. Okay, so we want it in that ax plus by equals c. Okay, I want it in standard form. So I will go ahead, I'm going to add 5x to both sides. I end up with 5x plus y equals negative 3. It's now in standard form, and it's easy for me to find my intercepts, right? If I want to find the x-intercept, okay, the x-intercept is going to happen when y is equal to 0. So I'll plug in a 0 for y. So I got 5x plus 0 equals negative 3. And then I'll solve for x. Well, that's just 5x equals negative 3, and divide by 5. That is going to be x equaling a negative 3 over 5. So there's my x-intercept. Okay, it's going to happen at negative 0 or negative 350. So let's write that up there. And then my y-intercept I'll do the same thing. I got rid of my equation. So I got a 5x plus y equals negative 3. Okay, so my y-intercept is going to be when x equals 0. So I plug in a 0 for x. 5 times 0 plus y equals -3. And so I end up with the y-intercept being at -3. All right, so my y-intercept is at is at 0, -3. Okay, so let's plot those intercepts at 0, -3, 1, 2, 3. That's my y-intercept. And then my x-intercept is -3/5. Well, that's somewhere over here. All right, it's going to be less than -1, greater than 0. So let's say it's like over here. I need 2 points to graph my line. I got my 2 points. So I can graph my line. And this is kind of difficult because Miss Bennett is on the computer. I know you guys are laughing at me now as you watch this, but there we go. There's my line. All right, let's go to the next one. The next one, guys, they have the equation. They tell us to find the x and y intercepts. I'm going to put it in standard form. So I want to move my x over. I'll have 4y minus 10x. Let me put my 10x in the front equals -24. So I got -10x plus 4y equals -24. But here's the deal. Remember, a cannot be negative, so I'm going to multiply this by -1. And I have 10x minus 4y equals 24. Now I have it in standard form. So let me catch up with myself. Minus 4y equals 24. Okay, same thing. If I want to find the x-intercept, I plug in a 0 for y. And that's going to zero out everything here. So 10x minus 4 times 0 gets rid of everything here. This goes away. And I just have a 10x equals 24. Divide both sides by 10. X equals 24 over 10, or let's simplify that. That would be 12 over 5. So I know one of my intercepts happens at, my x-intercept happens at 12 over 5, 0. Now I'll do the same thing, except this time I'm going to, I always keep getting rid of my equation. This time I'm going to zero out the x value to find the y-intercept. All right, I'll zero out the x value to find the y-intercept. Okay, so what I'm going to do is, again, all right, I plug in my 0 for x, and I end up with a -4y equals 24. Divide by -4 on both sides, and I get a y equals 6. So my y-intercept is going to happen at -6. So my y-intercept is going to happen at 0, -6. And let's go ahead and plot that. -6. 1, 2, 3, 4, 5, 6. So we got a y-intercept right here. And let's plot the 12/5. 12/5 is a little bit greater than 10, or 12 is a little bit greater than 10, so we know this is a little bit above 2. It's about 2.5. Okay, so about 2.5. So we're going to plot this here. And I got my two points. I can graph my line. There we go. All right, let's go ahead and talk about writing linear equations. They give us the example, or they tell us to write an equation in slope-intercept form with the given information. Remember, we need to use, if we're writing an equation, we're going to use our point slope. And then from there, we put it into whatever form they give us. So y minus y1 equals m times x minus x1. Okay, where where m is the slope, x1 and y1 are the y-intercepts. Is the point. Not y-intercept, it's the point. With that being said, guys, I look at 19. 19 actually gives us a slope and a point. So this is perfect for our slope, our point slope form. Okay, so I'll just plug in the point. I plug in the x part of the point into the x1 and the y part into the y1. So I would have y minus 3 is equal to my slope, which is negative 2 times x plus 8. Now they said they want this in slope-intercept form, so I simply just distribute and isolate y by itself. Slope-intercept form, remember, is y equals mx plus b. So I'm going to distribute my slope in. I would have a negative 2x minus 16, and it's equal to y minus 3. And then I would simply add 3 to both sides. And so I have a y equals negative 2x minus 13. Okay, slope-intercept form. Number 20. They tell me to write an equation with the points. They give me 2 points this time. So I'm still going to use my point slope form. I just have to find the slope. So I have to do one extra step. So the slope, remember, is subtracting. It's the difference between the y's over the x's. So y1 minus y2 over x1 minus x2 was how I found slope. And the big thing with slope is make sure whatever point you start with, you keep them aligned. Like you keep their x's aligned when you're finding slope. Okay, so I am going to start with negative 7, 3. All right, so my y on this first point is negative 3. Okay, which means that my negative 7 has to go first in the denominator. Okay, then I'm subtracting the y of the second point is 6 over the x, which is 5. Okay, so my answer here would be a negative 9 over negative 12. If I simplify that, my slope is going to be a positive 3/4. And now I can use my point slope form. Okay, I'm going to use the 0.56 that they give me. And then I use my slope. So I'll say, hey, y minus 6, which is my y, equals 3/4 x minus 5. You can use the other point as well. Okay. I want to put this in slope-intercept form, so I have to distribute this negative 3, or this 3/4, sorry, throughout the parentheses. So I would have a y minus 6 is equal to 3/4 x minus, and that would just be a 15/4. I got to get rid of this 6, so I have to add 6 to both sides. while I do that, I'm going to rewrite 6. Okay, so when I put it on the right side of the equation, I'll rewrite 6 as a 24 over 4, just so I have a common denominator. So this is 24 over 4. And if I add those together, I get a y equals 3 over 4x plus 9. 9 over 4. Okay, for 21, 22, and 23, this is our real life scenarios with linear equations. So we need to be able to define each one of our variables and write an equation to represent the following situation, then solve. Okay, for 21, it says for commission as a realtor, Michelle earns $349 plus 3% of the purchase price for each home she helps to buy or sell. Then it asked us, hey, if she earns $8,965 in commission on a certain home, find its purchase price. First, we're going to go ahead and write an equation based on how much Michelle earns. Okay, so let me define the variables. If I want to find out how much Michelle is going to get or her commission, right? Let's say C is the commission. I know that's dependent upon her purchase price. Okay, so I'll just say that the price. P is price. So if I'm writing an equation for this, I know what happens is her commission that she gets is first, it's going to be $349, period. So $349 is what she starts with. And then we'll add on to that however much, or 3% of whatever the purchase price is. Well, if I think about that, 3% of the purchase price, well, that's just taking the purchase price, and I'll call that P, right, times 0.03. That equation gives us Michelle's commission. Now, if I want to figure out how much she earned or if she earned this amount of commission, $8,965, if I want to figure out what the purchase price of that home was, I am going to plug in 8,965 into the equation for her commission, okay? And then I'll just solve for P. So I have 8,965 as her commission, and it's equal to 349 plus 0.03 times P. So I'll subtract 349 when I subtract 349, let's see what we get. So I have negative, let's see, I have 8,965 divided by, or subtract from 349. There we go. We end up with a 8,616. And that's equal to 0.03 3p. I'll divide both sides by 0.03. Ooh, I get my purchase price was equal to 287,200. 287,200. Let's look at Ryan's situation. On Ryan's last social studies test, there were two types of questions, true and false, which were worth 2 points each, and multiple choice questions worth 4 points each. If Ryan earned 86 points on the test and answered 18 multiple choice questions exactly correct, how many true or false questions did he answer correctly? So let's think about all the variables happening here. First thing I'm thinking is Ryan's score. Okay, so we'll say S is his score, or how much he got. And then I know that there are true false questions. So I'll just say X is going to be the true false questions. And I got another variable happening here. I got the multiple choice questions. I'll call those Y. I'm going to just say multi-choice. Okay. I can write an equation based on the information they gave us, right? I know all the true or false questions were worth 2 points each. Multiple choice questions were 4 points each. So if I have to write an equation for his score, it's going to be that his score is equal to 2 times his true or false point, or his true or false questions, which is X, plus 4 times all of the multiple choice questions, which is Y. Okay? Now, let's use what they give us. They said, hey, he earned 86 points on the test and answered 18 multiple choice questions correctly. So we have to figure out the true or false questions. All right? So we need to figure out what X is. I'm going to plug in, do some substitution based on the values they gave me. Well, his score was 86. So I'll plug that in for S. It equals 2X, which I don't know what that is, plus 4 times the 18 multiple choice questions that he got right. All right, well, 18 times 4 is 72. So I'll simplify that now. And then I have my 2X equals 86. So now I just have to solve for X to figure out how many true false questions he answered. So I'm going to subtract 72 on both sides. Okay. And I'm going to pull this down so I can get some space. There we go. When I subtract 72, I end up with a 14 equals 2X. Divide both sides by 2. And I know that Ryan got 7 multiple choice answers correct. Or, yeah, was it multiple choice? True or false? He got 7 true or false answers correct. 7 true or false correct. All right, let's move on to 23. All right, the next scenario talks about a plane that is descending upon a runway. So it's in the air, and as time goes by, the altitude changes. So if we think about it, as the time goes by, the altitude goes down. So we know time is going to be our independent variable, and the change is going, or the altitude going down is going to be the dependent variable. All right. So X is our time and Y is our altitude. With that being said, we're going to write an equation to model the data using linear regression. Okay, so what we're doing here is we look, and I think if some of you have checked these points, you realize this is not a perfect descent. This is not a perfect linear descent. So when they say using linear regression, that means that we're going to find a line of best fit. Okay, so we'll just use the data that we have, and let's just find the best line, the line of best fit, and we'll come up with an approximation for an equation that models this descent. Now, so I can include everything, I'm going to start with the descent, and I'll do the descent all the way down to the last point. Okay, so I want to include everything that I see, all my data, just to get a line of best fit. So I'll use my top point and my bottom point. That's what Miss Bennett is going to use to write an equation that fits this model here. What I'm going to do is use my point slope form to write an equation. Y minus y1 equals m times x minus x1. Now, guys, we don't have a slope because this is a table, so I use the points to create slope. So if I look at this, again, the slope of a line is y1 minus y2 over x1 minus x2. So I need to plug in 2 points that I've picked from the table, and I'm picking the top one and the bottom one to include the descent as best as possible. So my y values are going to be 28,500 minus the 17,991. Okay. And then my x values will be the change in time. So at 0, when the plane starts descending, minus 5 minutes. And it makes sense. Okay, it totally makes sense that the slope of this will be negative, because if you think about it, this plane is going down. It's descending down, or the values are getting smaller. So it totally makes sense that I'll end up with a negative slope. So let's figure out what this slope is. I'm going to subtract 28,500 from 17,991. And that gives me 10,509. Well, I take 10,509 and I'll divide that by negative 5. When I divide that by a negative 5, and that's a negative 5. I accidentally picked 5, so I know this value is negative. I would have a negative 2,101.8. So negative 2,101.8. I'll use that for my slope. So I plug that into the equation, and then I'll just pick one of these points. I'm going to go ahead and pick the top point because it's the easiest to plug in. So I'll say, hey, y minus 28,500 is equal to negative 2,101.8 times x minus 0. All right. I will simplify this. I want to go ahead and get it in y equals mx plus b form. It's just the easiest to deal with. So I'll simplify this equation by distributing the 21,101.8 into the parentheses. So I would have a y equals negative 2,101.8x plus 28,500. What I'll do to find the height after 8 minutes is just plug 8 into the equation for x, right? 8 is our minutes. So I take y equals negative 21,101.8 times 8 for my 8 minutes that passed, and add that to 28,500. Now my answer better be less than 17,991, right? Because the plane is descending, all right? If it's not less than that, something is not right. So I get my handy dandy calculator. I'm going to type it in. Negative 2,101.8 times 8 plus 28,500, and that is, oh, I think Miss Bennett, I'm going to second entry. I missed a number because that is bigger, right? But that's because Miss Bennett missed a number. I missed my 0 here. So I'm going to second entry. If you ever miss an input like I did, you can just enter your line again. So I hit enter again and my line popped up. And now I'm just going to hit second insert, which is the blue above delete. Okay, it allows me to insert something, which is I need to enter that 0. I forgot to put that 0 in for 2,101. So there we go. And now this looks good, right? Approximately at 8 minutes, it's at 11,685 feet. Okay, so y equals 11,685 point, what was it, 0.8? 0.6 feet. And that makes sense. Okay, it should be going down. It should be less because our plane is descending down. Okay, so the next thing says, how long will it take for the plane to land? Well, when the plane lands, that's when my altitude is at 0, right? Because the plane is at the ground. So in order for me to figure out how long it's going to take the plane to land, I have to set this entire function or the entire equation equal to 0. When my altitude equals 0, that's when I'm on the ground. So I set the whole thing equal to 0. And I solve for x. When I solve for x, I end up with x equaling 13.55. So I know that the plane will land in approximately 14 minutes. All right, let's move along. Okay, the next topic is about the parent functions. And in this set on your review sheet, we have linear, absolute value, and quadratic. I gave you more parent functions than this. I want you to know them all. Be ready to identify all of them. I am going to put a link on the video where you can watch the video on the graphs of parent functions if you forgot your parent functions and you don't know where it's at and all of that. So we'll quickly go over what the linear function is, all right, as well as the absolute value functions and the quadratic functions. The key here is to remember that all of these functions intercept the x and y axis at the origin. I know my parent function for a line is y equals x, and that is just a line that comes straight through the origin, okay, with a slope of 1. My absolute value function is a v, and it's centered at the origin. It goes up by 1 on each side. My quadratic function is going to be a parabola. Again, the vertex for that parabola is centered at the origin. The rest of the parent graphs, again, I'll put a link on this video. You can check out the parent graph video. All right, guys, the cool thing about the next topic is we can now use our graphing calculators, right? I'm not going to spend a lot of time on this because we practice graphing absolute values. Miss Bennett is absolutely okay with you utilizing your graphing calculator. I'm also cool with you using Desmos as a tool. Since most of you are e-learning, even my face-to-facers, if you want to use Desmos, you can. I do caution you with using Desmos. I need you guys to really know how to do it on your calculator because Desmos likely will not be an option for you when you take the semester exam. You have to use your graphing calculator. I'll go ahead and show you Desmos just so you can see that those who like Desmos. So I'll move this out the way. I graphed the first function, and if you look at this, guys, notice it's outside the window. Desmos lets you just zoom out easily. Bam, I can see the entire function. If I need to be ready to find the vertex and know where the vertex is. Desmos, I can just click the point. It tells me the vertex. I know it's at 2, -7. Okay, if I want to find some intercepts to get an approximation to graph it, I can just click those intercepts. Desmos lets me know what those intercepts are. Okay, so you can check your graph that way. Be ready on your test to sketch a graph or identify an absolute value graph using the tools that you have. Be able to identify the vertex. Be able to state domain and range. If we look at the domain of the graph, again, we know all absolute value graphs, their domain is all real numbers. So this is from -infinity to infinity. Okay. If we talk about the range of the graph, well, this graph starts at -7 and then it goes all the way up to infinity. So my range would be -7 to infinity. All right. Let's look at the next one. Again, I'll just plug it into my calculator. This one I'm going to model using the calculator. On my calculator, again, if I wasn't here, I would hit the Y equals button. That takes me to the screen where I go ahead and type the function in. So this is -2. I do the absolute value. So I'm going to hit math. I scroll over to numbers, hit enter. The absolute value pops up, types in, and then I'll type in X and then +4. Now, I'm going to go ahead and hit graph. And it graphs that absolute value for me. Okay, if I want to figure out what the minimum is, in this case, I gotta, or not the minimum, I'm sorry, what the vertex is. In this case, I want to plug in, or I want to set whatever is inside the absolute value equal to 0 and solve for X. Well, we're lucky here. We obviously know that it happens when X is at 0. Okay, so X equals 0. I need to figure out what the output is. Well, I can either try to zoom in and check on my calculator, or I can just plug a 0 into this function. When I plug a 0 into the function, everything over here goes away. So I know that my output, or my Y value for the vertex, is at 4. vertex is at 0, 4. And now I can talk domain and range. I know the domain stays the same. It's all real numbers. Negative infinity to infinity. And the range on this, well, it starts up at 4, right? And we can just look again. We start at 4 and then it goes down to infinity. So I'll include, or I'm sorry, Miss Bennett is writing this backwards. I'm going to do a negative infinity first. And then this goes all the way to 4 included. Okay, the next set are the piecewise functions. Again, the piecewise functions are no big deal because we can graph those with our calculator. The big thing with the piecewise functions is that you're able to determine whether it's an open circle or a closed circle because your calculator will not tell you. Okay, I am going to just model graphing the piecewise function with the calculator, and then I am going to post the solutions for you. Okay, so if I want to put this in my calculator, I'll clear everything out. And I need to use multiplication when I enter the function in. So I'll use parentheses and I'll type in the first part of my function. So this will be a negative absolute value. So I got to hit math, scroll over, hit my absolute value of x plus 2. And then I end the parentheses and I do the conditions. Well, if x is less than 1, so I'm going to hit x, and then I do second math to go to my logic keys, okay? And then I'll go down to less than 1, and I'll end my parentheses. I do the same thing for the other side of my piecewise function. Change this to multiplication. So I have a 3x minus 5 in parentheses, and I set another condition, which is when x is greater than 1. So I do a second math to go to my logic, or my greater than, less than symbols, and I'm going to use x greater than 1, close the parentheses, then I'll go ahead and graph. This is not a good look, right? I can't see it, so I need to change my window. I'll put my window, my X-min needs to be, let me go back. My X-min and max are good. It's my Y-min and max. So my Y-min needs to go out further. So let's go to negative 10. My Y-max actually doesn't need to go up so high, so I can do 5. Let's see. All right. Look at that. I'll go ahead and do my Y-max higher just in case. Let's do 8. Okay. And if I zoom in, look guys, I can already tell I'm going to have a break here at 1. Look at that break. So there is a hole right there on the graph. I'm going to do, I hit that zoom key and I'll do a zoom box. I can tell there's a hole. Oh, I forgot. I have to hit enter, and then you drag the zoom box over, go down, and look at that. Oh, I got a jump. Okay, so a jump right at 1. Zoom out. All right. Let's go ahead and plot our function. And again, this is a negative absolute value. If we look at it, I can tell it's a negative absolute value at -2. So the vertex is at -2 and it's going down. And where is Miss Bennett? There we go. 1, 2. Okay. So it's right here. Vertex is it's going down. The graph is shaped down. But then when I get here at 1, and I want the precise point. So all Miss Bennett is going to do is just plug 1 into the absolute value. So I would have a 1 plus 2. Well, that's 3, and it'll be negative. So I know the point here is at 1, -3. So down here at -3, I'm going to have, and let me make sure, 1, yeah, it's right here. I have an open circle. So I got my open circle. Then I know from my calculator, I have a line, my line going up, and I zoomed in, so I know it's not down here, it's up here. Well, if I want that exact point, I'm just going to plug the 1 into the bottom part of the function. So I'll say 3 times 1, which is 3, minus 5, well, that's -2. So I know at -2, that's when my line starts, okay? So at 1, -2, 1, 2. So right here. And the slope of my line is 3. So I know this is going to just go up 1, 2, 3 over 1. So my line is looking like this. All right. Domain and range of this graph, guys. The domain of the graph, if I look from left to right, the domain of the graph, it's there. They give it to us, right? They give it to us, okay? I know that the domain is going to go from -infinity to 1. 1 is not included, so I do a parentheses, and then it's a union at 1, and it'll go all the way to infinity. The range on this graph, well, if I look at the range of the graph, it's -infinity all the way up until, and let's look at it. Is there a disconnect? Well, actually, if I look at the graph, there's no disconnect that happens here because my absolute value covers this jump, okay? So this is all real numbers if I talk about the range. The range is all reals. Okay, so here's your answer set for the first piecewise function. Again, just make sure you write in interval notation, okay? Make sure you write this in interval notation. So we would have -infinity to 1, okay? So our range is -infinity to 1. For the last set, again, just remember to write in interval notation. What we're not going to worry about is finding the roots and the end behaviors. And where the interval is increasing and decreasing, you don't have to worry about that. So we're just Xing those out. Just be able to graph the function. If I give you a function, if it's absolute value, I want you to tell me the vertex and be able to state the domain and range and interval notation. That's it. If it's a linear function, you're just going to be able to graph the function, and that is all. Okay? Be able to state the domain and range, of course. Here's my next linear function, the solution for that. Here is the last linear function. This is the solution for that. Remember, we're not worrying about end behaviors, and we are only focusing on domain and range.